Hello everyone and welcome to Queen City Bytes Meetup, Designing Resilient Systems with Apache Cassandra. Today Aleks Volochnev here, and I'm very happy to greet you at this event. And first of all, I would like to say thank you, many thanks to Christina and Lynn for hosting this event. It's a big pleasure for me to speak here. And we are about to start. Very good time to start. If you can see me, if you can hear me, please set that thumbs up in the YouTube chat so I will know what you are together with me and we can start. Hi Ahmed. I believe I've seen you at one of our previous workshops. That's great. Very happy to see familiar names. Yeah, we can hear you. So I will start slowly but smoothly. So this one, I don't want to spend too much time on the preparations. This one we are going to discuss today. The topic of today is the designing resilient systems based on the Apache Cassandra experience. And you know what? Apache Cassandra is a great thing to base any kind of our analysis and attempts to build better, more resilient and capable systems, because it's, well, one of the most capable systems in the world in this moment that's used by very many big companies, you know for sure. So, why do we speak about the things we are going to speak today? That's all because of Murphy. Whatever you don't like at this workshop, at this session, don't blame me, but blame Murphy and his law. Anything what can go wrong will go wrong. And that's just a question of the time. Today we try to investigate the general principles what help us to design better, more resilient and more powerful systems. And then that's based on the Apache Cassandra. Why it's based on the Apache Cassandra? That's a simple answer. Out of all the powerful distributed systems over the world, this one is maybe most widely used by the biggest companies and everyone who works with the big data. So today we will do a deep dive into Apache Cassandra architecture because of the features of the system and the things it provides for the users. Big data ready, and when I say big data, I mean real big scale, so we speak about dozens petabytes or more. We speak about linear scalability. We don't know how our system will grow, but we need to have some linear scalability. We may need more nodes to have more servers. How many? You will see in a moment. Then it's famous for its geographic distribution, so you may have multiple active data centers all across the world. Disaster tolerance, as there is no single point of failure to be discussed today again. Even full outage of a single data center is not a problem because clients can always proceed with the next available data center. So it's not what you call fault tolerance, but real true disaster tolerance. And highest possible performance. So those are the things we will speak about today, and that's the platform we will use to discuss on how it's designed. Luckily, it's an open source project, so it's really easy to investigate deeper. How big is big? We use it to call Netflix one of the biggest Cassandra users, and they have, last time I was talking with the Netflix guys, it was around 70,000 Cassandra nodes. Maybe now it's higher because of this year 2020 madness. You know, they use it to be even in higher demand than before. So I guess that gets closer to 100,000 of servers dedicated to work with Cassandra. And, well, pretty a lot of operations. Some of you may never met Apache Cassandra before, you think? No, of course you know Cassandra, and you use Cassandra moreover. Do you use Apple or MacBooks? Any iPhones? You use Cassandra because Cassandra is one of the main sources of truth for any kind of Apple products, with 160,000 nodes, servers working with Apache Cassandra and storing data, building clusters on this infrastructure. And this is scaling. By the way, we use it to call Apple the biggest Cassandra infrastructure in the world. That was wrong. I said it as well. I was wrong as well too. Sorry, biggest now deployment for the Cassandra is Huawei, with much bigger numbers than like 150. So, we will speak about disaster-tolerant design principles. And I have to sorry if you await from this session to be like a how-to. You go, you do this, you do that, you have resilient system. It doesn't work this way, because I'm very sorry, but it's still the fact. Different companies, different businesses, different projects have different workflows and use cases. So what we do today is not we are trying to build the how-to, but we are trying to do something better from my point of view. We are trying to walk through all the main general principles you need to know to build a highly resilient system able to scale as Cassandra scales. And first thing just a second. Yes. Okay. So, first thing we will speak about is replication, or I would better say that never have a single instance of something. Whatever you're trying to develop, always think of every running unit. You need to have 3 of them, even if you now find with one. If it's a development ecosystem, that's still fine. Staging, testing, it looks like it's fine to have 1 running server, 1 running service. But that's a mistake. Think of 3, not of 2, because when you have 2, you also, that's a trap in our mind trying to bring them together. But think better of 3. You always have to run 3 or more instances. Even if you don't need them right now, think what you will need them in the future. What does that mean? What does that mean, replication? Replication, data replication in case of Cassandra, or service replication in your case, it's a question of single instance of whatever you run is doomed, and that's not a question of if it will happen, if failure will come or not, but that's the question of time. So, failure is inevitable. As long as you have only single instance of something, of a service you are running, it will die. It's a just question of time. We have to counteract that somehow. And our easiest way to interact that is to run multiple copies of what you find crucial to run. So, as Cassandra replicates data, we may replicate services, but it's not so easy as it may look like. You cannot just start the second instance of your application. Mostly probably it's going to lead to some problems. What kind of problems? Let's talk a little bit about that. First problem we want to cover, and how do we avoid that? That's inconsistency. Inconsistency in general, very simple and very bad thing. Imagine we have a situation, you're working with data and your data is replicated as Cassandra replicates data, and data is replicated into multiple nodes. If we run an update, we change something, we change username or account state maybe, and some of the nodes were updated and some of the nodes weren't. It may lead to problems, because, well, when you may query stale data, that's what called cross-node inconsistency. So that's a big problem. Why it happened in general? So take a look. As long as you work with single instance, so no distributed system, you may ignore this CAP theorem, but as long as you start to work with distributed systems, you really have to focus on that and you have to learn that as a law. CAP theorem, also known as Mark Brewer's theorem, speaks about distributed systems. And in the distributed application, that's impossible to simultaneously deliver more than 2 out of 3 following capabilities, guarantees: consistency, partition tolerance, and availability. What does that mean? So take a look. I will briefly describe every part of this combination. Consistency means what every one of your service, of your nodes, return the same value, the most up-to-date value. If database is consistent, you may ask every of the nodes of this database, every parts of the system, and they will return the same value. If database is not consistent, you may deliver stale data, which was updated for other nodes, but this one didn't get the update somehow. Second thing is availability. Availability means what you always get the answer. It may be stale answer, but at least an answer, not a 500 error code, response code. You got my answer. Highest possible availability means what you can lose node by node and cluster by cluster, data center by data center, but as long as one server is running, you can get your response. That's what we call highest availability. And partition tolerance is the ability of a system to survive network partitioning. And if you aren't too much into networking things and distributed systems, that's a little bit more interesting point to explain. It means what you may have lack of network connection, not between your client asking for some data and your database server, but between some of your database servers. And that's a very bad thing. That's, for example, if you work with PostgreSQL or MySQL, if you have some situation of a split brain, network partitioning, also known as split brain, when you have some of your servers on one part of a network, some of your servers on the second part of your network, and then that's a big problem. Because if a second part elects a new master, or you arrange a new master, as a result you have two masters or two primary servers, and that will work not so good. So you have to remember what there are 3 primary features, and in the perfect scenario, if you have no network problems, if your power supply is always perfect and there are no rains in the skies, you may have all 3 of them together. If you live in the real world like I do, then you have some problems, because at some point something will happen, and at this moment you cannot reach all 3 of the features you want to reach. So what we have to think is how it works and which is most important for us. For any kind of a distributed application, we cannot sacrifice partition tolerance. And when we have to decide if we have to stay highly available and partition tolerant, and highly consistent and partition tolerant. So the trade is between availability and consistency. And at every moment of the time you have to understand what you are sacrificing. If you are waiting for the response for all of your nodes to keep it always fully consistent, then that's a problem. As long as one node is not available because of a network problem, you cannot get answer and you are not highly available anymore. But as soon as you decide, okay, I can sacrifice 1 or 2 answers, but I want to be highly available, then you cannot guarantee consistency, because maybe the node, the answer you didn't receive was the only one updated node. Okay, then, now after all this story, you may be like, okay, how the hell distributed databases work at all? And well, I cannot say for every distributed system in the world, but as the example for us, the main lab sample for us is Cassandra. I will speak about Cassandra. We cannot break CAP theorem, but we can adjust settings. What does that mean? Very simple. Every application works with data of different importance. At the same application, you may make, I don't know, a money transfer, and you do want it to be very consistent. And at the same moment, your friend may have changed a profile picture, and you are very fine if you open page and you get profile picture which was not finished the full update, and you're receiving the old one, which changed like half second ago, but you are still watching the previous one. It's not a big deal, you can survive that, but you do want to be strictly consistent about your money. So you see, same application, different importance. In Cassandra, the CP theorem problem is passed on the per query basis. When you do a query for your data, like you are writing something or you are reading something, you can explicitly specify which kind of a consistency level you may want to have right now. So if you are working with like very secondary data, throwing some logs, throwing something what will not be required after a minute, you can go with any. That's pretty dangerous ground. You don't want your bank, and banks are using Cassandra a lot, you don't want to use your bank, use any for any kind of your transfers. No way. But when we have something with a higher level of a consistency, and we are starting with 1, 2, 3, local 1, quorum, what does that mean? It means of how many of the nodes we wait for confirmation before we consider data written, or before we consider the data we read as consistent. And in this case, that's one node. We wait only for one answer. Of course, that's dangerous, but the fastest. 2, 3, the same. But here, interesting thing comes: quorum. Quorum means the majority of the nodes. So if I have, for example, 5 nodes, I will wait only for 3 answers. And if they matching, if they all okay, approve it, then I'm done. My write is done. And the same applies for read as well. So we're giving matching data. If I use all, then I will wait for all responses. But do you remember what is the CAP theorem says? Only 2 or 3 are achievable at the moment. So if you decide to go with consistency level all, you are getting immediately into the consistency and partition tolerance by the price of the availability, the only thing we can trade. And at this moment, you are losing availability. One server is not available, you are not highly available anymore. So how to treat them? Here is a nice mathematical trick. We want to be quick, we want to keep highest possible level of availability, but we also don't want to have stale data. How do we handle that? Very easy. In general, in short, if you write your data on the quorum, getting confirmation for all of the servers you are working with, and if you read the data on the consistency level quorum, getting the most up-to-date data from quorum or from the majority of your servers, your services, then you are always consistent, because it's cannot be the situation when you have quorum write, quorum read, and you are still getting stale data. Very simple. You will get the notification if quorum cannot be reached in this case, and you will identify the situation and you will not dispatch stale data. So usually that's how it works, and by the default settings, majority to write, majority to read means immediate consistency. It's called immediate consistency. Okay, so we discussed CAP, and that's a big thing, but we have to move on. Here comes one more problem to discuss before we go on from the replication topic to next one. Stateful services. Typical example to explain the web services working with user sessions. When you find web store, you are looking at nice t-shirts, you want to buy a couple of t-shirts, and you work with one of their servers, and let's say it will be service A1 instance. You are good. But what can go wrong? Your user session is written only in this instance, like a normal simple web application store session data in files. And if by any reason your query goes to service A2, so the same service, but the second instance of this service, what will happen? There is no session stored, and you just picked up all of the best t-shirts you want to buy, and boom, your cart is empty. On next query it's full again, on next query is empty. Why? Because your queries are balancing between multiple service instances, and some of them have your session, some of them don't, and you have to log in, log out again, and so on. If you are working with the application and then boom, you are logged out and you have to log in again, it may have been this exactly the situation of user session instance of the service is not available anymore. They're running a new one. Your session is not transferred. You have to log in again. I bet every one of you met this situation before because that's a common case. Okay, so I say stateful services are bad. Try to avoid them. So how do we avoid them? First point for us would be sticky sessions. Sticky sessions is an interesting idea. It keeps a load balancer in front of your service instances and remembers the first server you contacted. And after that tries to route all your queries to this particular server. So it means what all queries of a user A will be processed by an instance service A1, and all the queries of user B will be always processed by service instance number 2. It's a good idea, it works, but it also has one strong downside. If you have to drop a server, you are planning an upgrade or you are planning something to change, you want to take it down, you want to restart it, put an upgrade, whatever, then with sticky sessions, it's kinda impossible to handle. So the only thing you can do is to inform your customers what you maybe will be logged out in a couple of minutes. That's definitely not nice practice. And so session stickiness is a special story. There is another interesting way, which is a shared state. In our case, you try to isolate all the state out from the services, making them as stateless as possible, preferably perfectly stateless. And then you go and services A1 instance, service A second instance, don't store user session at all, but they're getting that from any kind of a quick key-value database, maybe RocksDB, for example, and it allows you to work very, very quickly, loading data from that, and that may introduce a tiny delay because, well, quick file operation may be quicker than a network operation. It depends on your network and it depends on your file system, of course. But in general, it works pretty well. And then you are planning to scale out your application. You absolutely must think about shared state, and you must think about how to make your services as stateless as possible. Typical thing, as said, are the user sessions, but there are much more. So you have to find out a way how to make your services as stateless as possible. Sticky sessions will work, but it may be not the best approach you may use. Okay, are we done? Hardly started. There are a lot of things to discuss, so let's move. Distribution. What kind of a distribution? What does that mean? Very simple. What stay together is doomed together. Again, it's a question of time. We have to distribute things like we distribute them in Apache Cassandra. We distribute them over the world, over multiple data centers, as Cassandra is designed to have multiple active data centers over the world. It also a long story. There are some points to consider. First of all, any kind of network communications, especially when we have, for example, here, me located in Germany and Eric Ramirez in Australia, you know what? That's obviously going to be a network delay between two of us. What does that mean? Work with local data center. That's what matters. Work with the one instance which is close to you while keeping other instances distributed. How to start if you have a tiny application? Well, if you have small application and you think how to avoid risks like that, you definitely want, at least if you're working with a normal data center, to put your services running into different racks of this data center. This way you avoid network delays while at least avoiding single rack failure, then all of your servers are staying in the single rack. If you're already in the cloud, that's much easier, because then you can go from one availability zone to another, having your services running in availability zone A, B, and C at the same time. If you covered replication problems discussed before, when you will be fine. And a few more things to talk about how exactly are you going to handle this distribution and route any kind of network queries services are doing to each other. There are three main things. Cluster schema, so how which service located where and how do they work together. If we speak on a higher level, we can use Anycast IP or DNS load balancing. So what does that mean? Cluster schema is not exactly our way in this case, because we want our services to be more flexible and easier to use. So we think of better things like on a global level Anycast IP or DNS load balancing. What does that mean? First point. DNS load balancing is the way easiest to explain. You have your instances of your application running in multiple data centers. United States West, United States East, Europe Central. Very good. And you can have completely one single domain name for all of them, myperfecttshirtshop.com. But depending on the geographical location of who is asking of a customer, it will receive different IP addresses. So that's what call it DNS load balancing. If you are located, most of you, I guess, located in the United States, are doing question for myperfecttshirtshop.com, you will get one IP address, and I'm doing the same query in the Europe, will get another IP address. That allows us to go to work globally in multiple centers, in multiple data centers. That's especially convenient with the cloud, of course. So things like AWS or Google Compute Platform have native services to support these kind of things. That's very great. Another option, which is more advanced and even cooler, is Anycast network routing. Anycast is like low-level networking thing, but I want you to know it just because it's really cool. That should be completely enough. Anycast, how do you think one single IP address, how many servers may have this IP address if they work in the global internet network? Answer is basically as much as you want. A single IP address may be registered for multiple servers, and then you may ask, how does my laptop decides which of them then to access, because servers are different? Answer is that's a question for a router, and router picks the closest one. So if multiple servers announce the same IP address, routing, mostly probably of your ISP provider, internet service provider, will pick the closest one automatically. So Anycast IP network addressing is the coolest thing, which is not so easy to organize. So mostly probably if you are going to use Anycast, you are going to have an experienced network engineer, and that's, well, not as simple as just normal network address. But it's really one of the coolest things you may use from the point of view of the network balancing. And moreover, it also has automated fallback. If you have multiple servers with the same IP address and closest one to one of your clients by any reason is not available anymore, whatever happened, that doesn't matter. When what happens? This IP address will be deregistered by your internet service provider router, and all of your queries will go automatically to the next closest IP address. Also cool. Downside, there is a time gap when this IP address is not deregistered yet for the missing server, and at this time parts of this region may be detached. So that's the side I don't like. As you see, DNS load balancing might have some better options as well, but any cast going to be fastest anyway. Okay, you know what? That's not enough. Even if you have multiple servers, but running on a single cloud platform, that doesn't matter. Guess what? That's just a question of time. We have seen network and power and many other outages by all the major, minor as well, cloud platforms and any kind of hosting companies over the world. All of them fail, and that's again just a question of time. So, good side, try to be as platform agnostic as possible, using proper tools like infrastructure as a code, for example, with Terraform, but that's a special topic to speak about. And speaking about many other things, that's very important to be able to run the same parts of the same application over the multiple platforms at the same moment of the time. And that's really cool, because that's exactly how Apache Cassandra works. That's one of the core principles. Be platform agnostic. Be able to run on every platform. Today it's Azure. Tomorrow you found out what Google Compute Platform gives you 50% discount on everything. Boom, migrate within 1 day. Okay, if you have a lot of data, it's not going to be 1 day, but still. And so on and so forth. What are the downsides? First of all, it's harder to manage. Of course, it's much easier to work with one single data center or one single provider. If you're going to work with multiple data centers from the previous topic, that's already a problem. But if you're going to work with multiple providers, then it's double trouble. So, and it's costly. Any kind of a data transfer, if you speak about the big data, any kind of a data transfer between multiple different network, cloud providers, for example, going to be pretty expensive. So, this one approach is for everyone to discuss on your planning meetings. What do you really want to have? And you have to watch your SLAs, service level agreements. What's the level of uptime you want to deliver? How quickly you want to deliver your responses? And you have to understand what every next percent of the uptime comes with higher and higher costs. So at some points you have to stop. And if your application have no SLAs, you really have to stop, quit this meetup right now and go and read about what the SLAs and SLOs are, because that's very important. I'm kidding, of course. Please stay with me till the end. But that's really important. You have to clearly understand what are the requirements for your application and what do you want to have in the end. And even if you don't have any like fixed formal service level agreements, you definitely have to define, at least for yourself in person, your service level objectives. Service level objectives are important. Agreements, they are for customers, kinda. Then signing contracts, you're going to deliver something for Microsoft. For Microsoft, congratulations. Then we have to sign a contract, and agreements go to contracts. But what you always need to have, even if you're running a tiny web store, I don't know, based on, God bless, WordPress, I don't care. You have to understand for yourself, what do you want to have and which level of service level objectives you want to have. Like, I want this website to be available 99%.99, and that would be enough for me. Then the costs can be pretty small. If you want to go higher, you have to pay more. Sorry, there is no free cheese. Durable design. Some more things to cover that. Very important to remember. Those services meant to be expandable, and those services meant to be replicable. And that's very important. Every unique service in your ecosystem is the bottleneck and the single point of failure. So you always have to remember the points of failure ever. Every part of a system must be expandable, replicable, and as stateless as possible. That's Always important to have that decentralized. On one of my former projects, it was pretty funny story. We were getting ready for a huge success on some marketing campaign, and we prepared everything from the scalability point of view. So we wanted to have a lot of that was a microservice based architecture, and we prepared everything to scale out. We prepared everything to be very ready to the new customers coming, and then it happened and application was not available at all. Why? Because we just forgot one single service responsible for authorization. And whatever we did, it didn't matter, because one single service became a bottleneck, a single point of failure. So you have to walk through all of your architecture without missing every single tiny service, without missing every single part. Find out and identify every part of them to find who is. If you are unique, that's bad. It's great when you are unique as a person. Every person is unique, but services must be expandable, not unique. If you want to have 5 of them today, then make 5 of them. Tomorrow 2 is fine. 2 is fine. Okay, no single point of failure. That's very important principle. And there is a very good example coming from DevOps world. Old story about cattle over pets. What's the difference between cattle and pets? First of all, pets have names. Cattle have IDs. If pet is sick, you will bring your friend to a veterinarian. If the cattle is sick, it's expanded. And your services, I'm sorry to say so, I believe you love your work and you love what you are doing as much as I do. They're meant to be expandable, they're cattle. So every service should not have a name, but only ID, every service instance, of course. And then, if you need to have more, run more. If you don't need them anymore, drop them. That's important. That's what called a durable design. You need more, you will have more. Next one, horizontal scaling. So first of all, there are 2 kinds of scaling, horizontal and vertical. What does that mean? With vertical scaling, now I have one middle range server, and it looks like I'm pretty successful on the market, so I'm going to have more people coming to us very soon, and I'm buying more powerful server, migrating my service to this more powerful, and that's what vertical scaling is. You are buying more powerful machine and moving to it. In comparison with that, horizontal scaling is very different. We are moving not to the next one bigger machine, but instead of that, we are scaling out to multiple amount of machines of the same level. Well, depends on your strategy, but more or less the same level. Commodity hardware, they're never too much expensive. The point is, if you do vertical scaling, you know how numbers start to grow at some point with just like every next click becomes too much and too expensive, even for the biggest companies. So what Cassandra does and what I recommend you to do, think of a horizontal scaling. If you follow the previous points and follow some other points from this session, you will understand you don't need to have powerful machine. You need to have enough of middle level machines to have your application successful. For the databases, it may be different, but for the normal application servers, think of horizontal scaling. That's a better thing. Possible downsides: the more machines you have, harder them to manage. Fleet management may become very hard in this case. 2 things to help and 2 things to consider: configuration management and infrastructure automation, or infrastructure as a code, another big thing. So configuration management, your configuration for servers should not be done manually. They should be done by the special software, configuration management software. Example, mainstream, most widely used now, Ansible, Chef, Puppet, There are some more, but those three are the main things to manage configuration over multiple machines. And infrastructure is a code. You may have heard something about Terraform, but also every cloud provider, if you go to a cloud, provides something about infrastructure as a code, infrastructure as a code. Yep. So for Google Compute Platform, it's going to be Cloud Manager, I believe, and for AWS, that's going to be CloudFormation. Horizontal scaling with no overhead. Now take a look. And for most of the applications, they can scale, but every next added node brings some overhead. It means what scaling is not linear, and on then every next step, you will have less and less addition to the computational power or storage capacity you are having right now. Netflix, one of the biggest not only users but also developers of Apache Cassandra, made a very nice experiment that's available in their tech blog. I recommend to read, very interesting reading. They scaled out a test cluster with Apache Cassandra from 50 nodes to 300 nodes, like 280, I don't remember exactly. And notice the results. That's a client writes by node with replication factor 3, so every piece of data is replicated 3 times. You know what that means already. And on every next, on the downside, you see the amount of nodes. Oh, I have a mouse. That's great. Here we have amount of nodes over time, and here we have writes by node count. You see this sweet long line. That means linear scaling. It means we can add more nodes, it brings no overhead. Try to watch things like that. If your system scales no linearly, it means at some point scaling will not help. If you see it's predicted to be in a far, far future, then it's fine. But if you're getting closer to this point, you definitely want to consider something. Then one more thing. Managing of a complicated system is a big story, is a big job. And for us, that's important to have a system as capable to manage its own problems as possible. Then it's great. Situation changes quickly. And if you are trying to do it manually, it's not going to work very well. When we speak about Cassandra explicitly, as it's our demo base for today, it's a schema-aware cluster. It means every node in the cluster, doesn't matter if you have 3 or 3000, knows which kind of data located on which node. If this node becomes the coordinator, it will serve a request, it will know whom to ask immediately. Gossiping. Nodes are communicating with each other all the time. No primary, secondary databases, but masterless systems. So all of the nodes communicating with each other of them, they are gossiping. So node understand all the time what this node is fine and it's my neighbor, it's close. Network response times is always very short. So that's my neighbor and it's healthy. And another node is also healthy node, answers always, but it's like way far from me. It's always very slow response. And okay, now I know who is my neighbor. And this node is not responding from time to time. I have to consider that. If I have to ask something and I can avoid this one, potentially sick node, it will avoid that. So that's a self-aware cluster, understanding how the different part of the cluster work or not work really. So you want to know. It also helps with early failure detection, as even before metrics on your monitoring showing something is wrong, gossiping may have a clue about what something is wrong in this part of network, and we can avoid that. And one more thing, of course, to consider is service auto-discovery. If we are speaking about no manual management, you definitely want adding a new node and decommissioning an old node. to be automatical process, and you don't want to go and manually register this new node of all of the nodes so we will know there is a new guest has come. You do one command and that's a cluster task to do that. And you know what? It's a long story because Cassandra is one of the most sophisticated systems we may have in open source, but that's definitely worth trying to see if your system may require something like that. Self-healing, and we are getting close to the end. Failure detection and recovery. Error will happen all the time. It's what? Just a question of time. You already know the answer. And I can tell, I was a developer for a significant part of my life. I was in operations. I was a DevOps engineer, one of the first, I would say. And I can tell the one thing which I hate developers the most. There are two things, actually. But one thing why I hate developers sometimes so strong, nearly no one cares about error handling. And then you, writing your code, don't care about error handling, then me on production have to handle this shit. So I do ask you, you are great people, you are attending meetups. It means you want to grow. Please handle your errors properly. It will be a very separate session I really want to do later because error handling is a great and highly underestimated topic. But in general, we are used to have missing error handling and recovery as a result of all of those things, usually very slow. People don't monitor what they have and people don't handle properly errors. As a result, there can be a mistake which happened a couple of months ago, and you will recognize that only then you are receiving message from your angry customer. Obviously, it means that's a very, very, very big fail. Error detection should be quick and automated. And on every kind of a potential fail situation, we have to write the code which knows what any kind of network operation may fail. Like developers are so optimistic, they usually forget what network operation may fail. And what worse? What can be worse when failed network operation? You are sending a network query to a neighbor service, and you don't receive a response. What can be worse? Answer is simple. Very, very, very slow ping. Then you get the answer. And you get this answer in half an hour. It means what this service instance was blocked for all this time. So you don't only have to wait for them. You don't only should expect network failure on any kind of a network operation, but you also have to expect slow response and always set the timeout and cut the connection if it doesn't work quick enough. Speaking about Cassandra things, there are multiple things. First of all, every node in the cluster is ready to dispatch and answer every request. It doesn't mean what every node stores all the data. If you have 10 petabytes of unique data, you don't want every server to store 10 petabytes of data because it's like just stupid. But what you really want to have, you want your nodes to understand where the data is located and which node to ask. But as a client, you shouldn't care whom to ask. That's a cluster job to dispatch the query to a proper replica node to answer. When you always have to think about the failure. If we fail on write, some of the nodes got update, some weren't because of network outage. Okay, node handling with query will write a so-called hinted handoff. That's Apache Cassandra word. So if you never met that before, that's perfectly fine. Hinted handoff means that the node what was dispatching the query, coordinator node, will store this data, and as soon as failed node recovers and notifies neighbors via gossiping, okay, I'm here, am I missed anything? Coordinator will dispatch this stored hinted handoff to one who was missing. But also many other layers of defense. Fail on read, wait for next response, decrease weight of a suspicious node, and initiate repair on read, for example, if required, if some of the nodes answered out their stellar data because, well, inconsistency is a big problem in the distributed systems. We have to remember about that all the time. And one of the sweetest things, operational simplicity. Lack of laziness is the developer's worst curse. And if you will look for the author of the quote, it's me. Because, well, it is. One of the worst sins of a developer is a lack of laziness. Only lazy developers may be truly efficient. And lazy developers, efficient developers, don't want to do the same job manually again and again. Manual operations are slow, very error-prone, and not transparent. And that's bad to have no transparent operations. Every operation should be traceable. All repeatable operations should be automated and traceable. And that's very great if your application may work with the data like that. What do we speak for when we speak about Cassandra? What does that mean? I bring a new node, and what does that mean? I need the data to be replicated and move it to the new node as well. I initiate that, but that's an automated operation. I don't care. I don't put any kind of data manually. If I decommission the node, if I don't need this node anymore, data from this node should be moved out to other nodes, so we will have higher density, but I can take down this one. It must be fully automated operation. Repartitioning and emergency rebalance when we have lost some nodes due to whatever, that's also must have to be prepared. These kind of more advanced steps, I guess, you will not do it for your perfect t-shirt shop.com. But when we speak about more advanced distributed systems, that definitely can be a very important thing. Again, that's really great then your system is able for self-healing. Typical thing we speak about the cloud deployments with auto-scaling groups, for example. If health check report this node service instance is not healthy for a few times in a row, this service instance must be decommissioned, and we will need to have a new one. And it must be automated process. That's what we have in clouds, with load balancers, health checks, and auto-scaling groups. But it's also doable on your own data centers if you prefer to work with your own data centers. For Cassandra, what does that mean? If you read some data, we write with quorum, we read with quorum, we know what data will be immediately consistent, but we can still find out what one of the nodes will not updated. What do we deliver to a customer? We deliver up-to-date data, it's consistent. But we also have to fix this not updated node. It's called repair and read, that's completely automated operation. I don't manually initiate repair and read, it happens automatically. Self-healing. On-demand repair, okay, of course, administrators must be able to initialize on-demand repair. For DataStax Enterprise, which is more advanced version of Apache Cassandra, but proprietary, we have node sync. And for Cassandra version 4, going to be released in some months, we are going to have some more interesting things, scheduled repairs, improved incremental repairs, and many others. So there is a lot of work in this thing. And you do want these to implement it automatically, unless you don't have 5,000 perfect operations, and you don't because no one has the sight of great operations, guys. And last one, continuous improvement. Debugging of a distributed system is indeed very, very, very hard. If you ever did transition from monolith to microservices before, you may know my pain. I did it for different projects multiple times, and I'm very curious why my hair is not white by now, because, well, debugging of a newly created distributed system is very, very, very hard. So, think ahead. Make logs great. Seriously. That's, by the way, the second thing I hate in developers. They don't write logs. And then they ask me, oh, application doesn't work in production. Could you please take a look at that? We have to fix that. Our customers are unhappy and our project manager is angry. And okay, I go to production, I open service logs to find out what's wrong, and you know what? There is nothing. Logs are empty. And how the hell now I'm supposed to debug this problem? Write the logs, please, I beg you. Thank you. Then, for the distributed systems, one more very important thing. Transient unique transaction ID. What does that mean? The point is, when you have your system of a single service, single application working on a single machine, you can go to this machine, open the logs of this application and read through all of them. You are a good guy, you are writing logs, so you are able to debug then and see what's going on. But when you have dozens of services running in hundreds of instance numbers, many of them launched in multiple instances, and then you have like some dozens or around like 80 of servers, let's say. I'm speaking about absolutely real life example. And you have some problem with some customers. What exactly you are going to do and which logs are you going to read? They all are on different machines. Even if you have logs, it will take ages before you will put them together, trying to analyze how do they match. So transient transaction ID is a very important thing. As soon as a request comes into the system from the outer user, so from end customer buying something, this request has to get an unique transaction ID, transient transaction ID, and then this transaction ID must be printed in every log output of every service on every server, running on every server, with exactly the same ID. That will help you analyzing the logs over the system, see what those and those are actually happen together. They were a part of a single transaction workflow. And that's just incredible how it helps to analyze logs and keep debugging your system. Moreover, that's nearly impossible without transient transaction ID. One last final hint on that. Usually you have two kinds of workflow initiators. Some of them are outside, so that's our external users, and some of them are your internal scheduled jobs, for example. They also must have those transaction IDs, transient IDs, otherwise you will be not able to debug half of your system. Then continuous monitoring, and everyone says monitoring, not so many people says continuous. You want to have your monitoring continuous, so you will be able to make predictions. Have you heard maybe of ML ops? That about things like that, getting machine learning into the things and making predictions about how your system will behave in the future. Very interesting topic. And you really want to work on that and to see how the situation changes with your system over time. But you know what? We developers, engineers are always thinking about software and hardware. But there is something which is much more important than any server and any kind of application. Let's say humanware or just people or teams. And the thing is, you may have best technologies in the world, but if you have a bad team, you cannot build a great system. And you may have like not so good technologies, but if you have great team, you will build a great system. That's about people. And what about people do? And you know what? People aren't perfect. People are doing mistakes, and we aren't here to blame them. Please. Post-mortem and root cause analysis are never about whom to blame. You know, I was born in Soviet Union, and we have like mottos like every failure, every outage has first name, last name, and job title. Let's get rid of this shit. Let's stop the blaming environment, and let's think how we can improve system. And there is one more trick, because, well, if you don't do postmortem, you have to do. And there is one more tip I can give you, which will help. If, as a result of your root cause analysis, you found out what it was a human mistake, it means what root cause analysis is not yet done, because you always have to get deeper, because people will do mistakes, so you always have to think how to prevent those. That's the point. Conclusion. We are almost done. If we speak about those topics a lot, you see we have a pretty big list. Replicate services, distribute replicas, diversify infrastructure, have no single point of failure, scale out, and so on and so forth. And that's like a long list. You know, if you have 200 action items, then mostly probably that's not a great situation for you. What I prefer to think here, how I prefer to think here, is think only about very simple thing. Very simple, the main principle. Expect failure, praise failure, design to fail. Take a look. We may think to try to have the system available 100 times, but that's not possible, because failure is inevitable. Again, that's very important to remember. So what we want really to have at some point is we want to think of having our mean time to recover equals 0. When we have multiple nodes and we have multiple service instances distributed over multiple data centers, even if some of them fail, we will be always able to recover. And for me, it's not about 100% uptime, but about mean time to recover equals 0. So I want to recover quickly. Then I always have nodes to answer. As Apache Cassandra does, I will always deliver my response. And that's it for today. And the only one last thing I want to do with you is play a little game. Our great DataStax company I work with generously supplied some prizes for a little quiz we are going to run right now. And as we don't have too many people today, everyone have chances to win a prize. Don't expect anything big, don't expect houses and cars, but that's definitely going to be interesting to compete and win something. So, to participate in our quiz, please go to menti.com and enter the code 763323, or simply scan this QR code and join our nice competition. So I really want to see some people joining. Again, that's menti.com 763323. Notice that's completely anonymous. You don't have to put your email address. You don't have to put your credit card or whatever. That's completely anonymous, okay? We just need you to join and scan this QR code or enter menti.com using the code. Easiest way to do that is just by using your mobile phone. That's really the easiest way to join the quiz. And I think we have some people. If you have joined us, please press thumbs up so I will see what we have more people and we can start. Okay, I want to have a couple of more persons. I will give you 30 seconds. We are almost done. So there are last final questions. Don't miss a chance to win some swag. We have nice t-shirts and cups and some more actually. Eric, do you remember what do we have in the winner set right now? I don't remember. It was t-shirt, it was cup. But okay. Anyway, those are great, I'm sure. So, I'm going to start. 5 last seconds. Okay, I see some more people have joined. So, let's play the game. Question 1. and I'm going to start. Yeah, we don't have a lot of people today and 7 questions to answer. Answer fast to get more points, but you don't want to make a mistake. Apache Cassandra is an SQL database, a NoSQL database, a MySQL database. Please watch your phones because YouTube has a delay, 1-2 seconds. Watch your phones, they will be more on time than YouTube. Correct answer is a NoSQL database, and someone answered an SQL database. Well, that's non-relational database. So yes, correct answer is the second one. And let's move on. Who is going to be winner after the first question? I see. So it looks like it's Joanna. Joanna, congratulations, 895 points. But Snuggles is very close with 888 points. And well, that's just the beginning. We still have 6 more questions. Question number 2. And I hope you're ready and warming your hands right now. So let's go. Answer fast to get more points. We replicate services to achieve fault tolerance, consistency, inconsistency. And the correct answer is we replicate services to achieve fault tolerance. At least no one have answered it. We try to achieve inconsistency. That's good. It means I did something good today. But we do not replicate services to achieve inconsistency. Of course, to achieve consistency. Actually, consistency is the price we pay to have our services replicated. And how does that look after the second question? I see. So, Ahmed, Ahmed, that will be enough. Not so many attendees today. Congratulations. It was the fastest answer and you are getting the first place with 1,806 points and Montana is on the second place with small difference. Jerry keeps the third place and it goes pretty interesting. So let's go further. Question 3. And you still have to answer fast. But don't make mistake. CAP theorem says what in a distributed system, consistency, availability, and partition tolerance all can be achieved. 1 of 3 can be achieved. 2 of 3 can be achieved. That's an interesting one. I can't wait to see your answers. So time is up and the correct answer, 2 of 3 can be achieved. Or we speak usually about consistency and partition tolerance or availability and partition tolerance. And we can try to keep balance as we do with Cassandra. So leaderboard. Who was the fastest now? I see people are answering pretty quickly. And Lola was fastest, and that's a great result. But that's yet not enough to get to the top 3, and top 3 person get the prizes. So top 3 at this moment looks like Ahmed, Montana, and Jerry. So keep fighting, it's not done yet. Question 4. Focus. Sticky sessions help to stick a user to a service instance, stick a service instance to a database, stick a post-it note to a user. So, how it goes? Okay, so in most of the implementations, sticky sessions help to stick a user to a service instance. They not to stick a service instance to a database, and definitely not to stick a post-it note to a user. So let me see the leaderboard. That's not so many people today, but the competition seems to be interesting. And Jerry, it was a mistake. Oh, that's interesting. So we have changes there. Pavel Montana gets to the first place And moving Ahmed to the second one, which is still good. And Jerry now holds the third place again. So let me take a look what comes next, because that's getting more and more interesting. And that's the question 5, and we are getting close to the end. Who will be the winner? IP network addressing, what allows multiple clients to share a single IP address, called Everycast, Anycast, Abyscast. I'm very curious how many of you paid attention to these kind of things today. And the correct answer is Anycast. Everycast, well, it's a little bit different, but Anycast is the thing what allows multiple clients to share a single IP address. Very well, and there is no thing like Abyscast. I'm very curious who has answered that. So let's take a look. Okay, a lot of mistakes this time. What will change? Game a little bit. So Pavel Montana and Ahmed Benaya keeping first and second place accordingly, and Ahmed was fastest. But due to mistakes, mistakes of others, Vladimiras gets to the third place, reaching this top 3 list, which is great. So congratulations, keep fighting, it's not done yet. But I believe we know already top 2. Don't make a mistake. That's a tough competition today. Question 6. Answer fast to get more points. What is the SLA? Service level agreement, service level achievement, service level attempt. And so quiet in the chat, everyone is on the mobile phones clicking. Very good, that's exactly what I want to have. Correct answer is SLA is service level agreement, the promise you give to your customer which response time or which uptime you are going to reach. That's perfect. And what's coming with a leader? Pavel, I can't believe our first place makes a mistake and lost the first place to Ahmed, getting to the second one, and Vladimiras answers correctly, keeping the third one. That's incredible. And so we have last question. So I'm nervous. I have to admit I'm nervous. Let me drink some water. I love quizzes. That's always a great part of a session. Answer fast to get more points. SPOF is a single point of faint, single point of failure, stateless patch of fate. That should be an easy one. That stateless patch of fate, of course. I believe everyone gets that. Okay, and the correct answer was single point of failure. And that was the last question for today. And we can take a look at the leaderboard. And oh my god! Ahmed, how could you? Now I'm really curious. Okay, so Pavel Montana gets to the first place with 5,251 points. Ahmed gets to the second one with 5,232 with so minor difference. And Vladimiras successfully keeps the third place. I kindly congratulate every one of the winners. So top 3 people, please. Oh, Ahmed missed the button. Okay, but anyway, second place gets the same prize, so you have nothing to be too worried about. Now, please make the screenshot or I don't know photo of your mobile phone or whatever you are using now with the results, and find me. You can find me in 2 different ways. First one will be Alexander.Volochnev at datastax.com. Looks correct to me. Or what is better, find me at LinkedIn. So it will be even better, because I really want to make friends with every one of you at LinkedIn. It's great to have friends with the people who are interested in getting better in their jobs. I'm very happy to see you all today. And I believe we are out of time, or at least very close to that. So thank you. Thank you, Christina. It's a big pleasure, and thank you for thinking of me. It was a big pleasure to participate in your meetup. That's great. Take screenshot of your Menti, contact me, send me a message on LinkedIn or via email, whatever you prefer. And I can't wait to see you on our channel again. We stream it, this meetup, with help of a YouTube DataStax developers YouTube channel, and you have a button. It should be somewhere right behind me. Like, subscribe. That's what you have to push today, because if you stayed with me for more than an hour, or actually, yeah, for more than an hour, it meant you liked this session. I know you liked that, so that's a good time to push the button. Thank you so much. And I think we are done. That's incredible. And for no doubts, we will see each other again. So thank you, Christina. Thank you, Lynn. And that all was a great pleasure. We will meet again.